Hello, my name is Chamith, and I will be talking about the investigation into the significance of wind energy. So, here's an outline of what I'm going to talk about. First, I'll start off with the historical background and global significance, and then lead into the technical description, and then eventually talk about the life cycle analysis and the impacts of economical, environmental, and social impacts. For the history, mechanical wind power originates as far as 3,000 years old in Egypt, where windmills were used to pump water. Ancient civilizations have used wind-powered machines to obtain grain from the soil for agricultural purposes. In this picture, we have the early stages of wind technology development. As you can see, as it progresses within time, you get a better wind turbine technology, and eventually the modern wind technology with wind farms over here in California. Global distribution of wind energy. In the 1990s, you can see that North America dominated the wind energy sector by 79.9%. And 1995, you can see Europe getting into the trend right there, about 50.7%. That's about half the energy sector in wind energy production. And when it proceeds to the new millennium, you can see that Europe is basically dominated the wind energy sector. And now I'll talk about a bit of technical functionality of the wind turbine. These are the major components of the wind turbine. You have the hub, the rotor, the frame, the main shaft, transmission, generator, and eventually the tower to hold the wind turbine. The momentum of natural wind from the earth applies a force to the rotors on the turbine of the shaft, which generates mechanical power. This rotating mechanical power is then converted to AC electrical power through conventional AC generation techniques. A more detailed block diagram of the major components on the figure before is shown here. As you can see, the wind is described by the arrows, and when it hits the turbine, the pitch angle rotates the rotor over here. Typically, induction generators are used in wind turbines because it can withstand strong wind speed variations with better mechanical compatibility. Additionally, an induction generator can be purchased at a lower price compared to a synchronous generator over here, and this is eventually flowed into the grid with the help of transformers. And here's the power formula for wind energy power calculation. It is derived from this equation, and the power coefficient depends on the size of the turbine, which varies within each turbine. This is a control mechanism which is implemented in wind turbine technologies, and over here we have the VDC link voltage, and so it is used in wind energy conversion systems. With varying speeds, the generator must still produce reliable electrical energy. This is done using a self-excited induction generator, which includes a self-protection mechanism. Most wind turbines use DC link voltage right here, even though wind turbines generate AC voltage because the rotating rotor would rotate in a stator and generate a AC voltage. It is first converted to DC. Why? Because it enables the power output of the turbine to be smooth and could be synchronized with the main grid. On the next slide, we have the AC voltage over here, which is the primary wind generated voltage. And when there is, see over here, this is the magnitude, this is with respect to time. when there is a fluctuation of AC RMS, like over here, the wind was there was a large amount of wind gusts, and suddenly it decreased due to variable wind speeds. So the AC has dropped by a significant amount, but the DC has only dropped by 5 volts, which means DC is much more controllable. AC generated power from DC looks like this. So it is done with a 3-phase inverter, and over here we have a wind farm which is generating electricity with the help of a gearbox. So let's move into energy storage hybrid systems. So in this diagram, we know that as the demand for wind energy increases every year, it is important to improve this technology to provide a more robust, reliable electrical power. More and more people are considering wind energy hybrid systems, which consist of an energy storage feature, which is a battery system when the turbines are online, and this battery system dissipates power when the turbines are offline. The battery is usually a lithium-ion battery, and it has the following advantages. First, it has a smooth power output, and this battery also increases system reliability by reducing risk of shedding. And finally, let's move on to the life cycle analysis of a wind turbine. In order to further investigate the pros and cons of wind farms, complete assessment of the life cycle analysis is required. The following sections give a breakdown of the life cycle and on an average wind turbine, which includes the construction and installation phase, greenhouse gas emissions during the construction phase, and information on the wind farms. So on the construction phase, you have the manufacture of components from rotor, tower, and foundation. This has been transported to the site erection, and in there it's been operated and maintained. Eventually, when the wind turbine is to be decommissioned, it is dismantled and recycled for more parts. And the total cumulative energy requirements to do this is as follows. First of all, there is not a lot of energy required to manufacture the wind turbines compared to conventional power plants, because essentially what you are doing is making the tower of the wind turbine and rotors from raw materials such as metal and fiberglass. But it is a good feature to talk about because the distribution of each turbine would allow engineers to design future wind farms more sustainably. So as you can see, the manufacturing process takes 84.4% of the energy requirements, and then you have transport on the next, and then maintenance, and then dismantling and operation. So now the greenhouse gas emissions from different power sources compared to wind power. There are no greenhouse gas emissions during the operational stage of wind turbines. However, during the manufacturing stages of each component, there are some greenhouse gas emissions, which are very low though. As you can see, it is really low compared to the other sources of generation methods. So it's quite significant. And now we'll talk about the onshore wind farms. Wind farms basically are a group of wind turbines that are located adjacent to each other with the intent of harnessing the wind energy in that particular location. Onshore wind farms are the most abundant type since it is generally easier to distribute the electricity to the grid when it's in close proximity. The wind power capacity generated by onshore wind farms are shown in this table. So we have China, which has the greatest capacity, and then next comes US. So now for the offshore benefits, there are not a lot of offshore wind farms because the disadvantage of having offshore wind farm is that it is far from the electrical grid. Therefore, more transmission lines are required, hence more losses. Um, we have in Europe we have UK leading with the capacity of wind farms offshore, and the advantage of having wind farms is that it's being exposed to more wind because offshore locations are more tidal winds from the ocean compared to land. Economic impacts. Here's a breakdown of the cost of wind energy that are used. Although there's not a lot of costs involved with wind technology, it will the onshore wind plant is between 4.5 and 8.5 cents per kilowatt hour and cause large variation in these prices with the availability of wind resources. Environmental impacts. As shown in the figure, most environmental impacts arise from the manufacturing of the components and decommissioning of the wind turbine. It can be concluded from the study that the environmental impact can be reduced during the manufacturing stages by careful design of the turbine and its components. Social impacts. The main concern from social impacts are the killing in wildlife. Birds do collide with the rotor blades of the wind turbines, and it is harmful for wildlife. In conclusion, I would say that wind energy is the most efficient source of renewable energy. Research should be done to improve its capacity, and more people and scientists, engineers should look into developing a stronger foundation with the wind technology. Thank you for listening to my video.